All right, so we have a story problem here. Elijah is thinking of two numbers whose sum is 73. One number is 10 more than twice the other number. What are the numbers? Show your work. First, we must decide what x will represent in the story problem. So x will represent the first number, and then y will represent the second number right here. Now, we can write an equation because we know that the sum of the two numbers is 73. So we can write x plus y equals 73 because sum means addition. Then for equation 2, we can write y equals 10 plus 2x because we know that one of the numbers, and I'm going with the second number, is 10 more than twice the first number. So 10 more than twice the first number is 10 plus, that's 10 more, and then twice means two times the first number. All right, so we have the equation y equals 10 plus 2x. Now, we have a system because we have two equations and we want to solve for the unknowns to find a solution. We're going to use substitution here. We're going to substitute the expression for y from the second equation in equation 1 for y. Then we can solve for x. So the first equation was x plus y equals 73. Okay? Where we see y, we're going to substitute in 10 plus 2x. So you can see that here in line 2. Instead of writing y, I wrote 10 plus 2x because I know from equation 2 that y is equal to 10 plus 2x. Now we have a one variable equation and we can solve for x. In line 3, I just combined the like terms from line 2. So x plus 2x gave me 3x, and I still had my plus 10 equals 73. Then in line 4, I decided from line 3 that I wanted to get all of my constants on the right side of the equation. So I needed to get rid of this 10. So I subtracted 10 from both sides of the equation. Once I combined like terms, I was left with 3x equals 63. And you can see from this line right here, I simply moved 10 to the other side. So 3x was now by itself and it's equal to 63. Okay. And I moved 10 by subtracting it from both sides. So effectively, I got rid of the constant on the left side of the equation with 3x in line 3. So now we have 3x equals 63. I still need to isolate x, so I need to get rid of the 3 right here with x. In order to get rid of the 3, I need to divide both sides by 3 because 3x means 3 times x. The inverse operation for multiplying by 3 is dividing by 3. Remember, whatever I do to one side of the equation, I must do it to the other side. So I divided the left side of the equation by 3. I also divided the right side of the equation by 3. On the left side, 3x divided by 3 gave me x. And then on the right side, 63 divided by 3 gave me 21. I know that x represents the first number because I said that up here when I started this problem. So I know that x is 21. So I know the first number is 21. Now I have to find the second number, which is y. So I'm going to substitute the value I just found for x in equation 2 to solve for y. Equation 2 is set up perfectly to solve for y. It's y equals this expression. So when I substitute the value for x in equation 2, right, I now have y equals 10 plus 2 times 21. 2 times 21 is 42. So I have y equals 10 plus 42 right here. And I know the second number is 52 because y equals 52. All right, so I found both numbers. This riddle has been solved. Now I'm going to check my answer. If there's any way to check an answer, you always want to check it. So I know my first number was 21. My second number is 52. And I know their sum should be 73 based on the story problem, right? Elijah is thinking of two numbers whose sum is 73. So I actually added the two numbers up. So I know that 21 plus 52 should equal 73. And 73 does equal 73. That's true. So far, this is great. Moving on, I'm going to extend my thinking. What is the difference between the numbers? Difference means to subtract, right? I want to figure out what is the difference between 52 and 21. How far apart are they? So 52 minus 21 is 31. So the difference is 31. That is all.